AI is coming for mathematics too. For thousands of years, mathematicians have adapted to the latest advances in logic and reasoning. Are they ready for artificial intelligence? In the collection of the Getty Museum in Los Angeles is a portrait from the 17th century of the ancient Greek mathematician Euclid. Disheveled, holding up sheets of elements, his treatise on geometry, with grimy hands. For more than 2,000 years, Euclid's text was the paradigm of mathematical argumentation and reasoning. Euclid famously starts with definitions that are almost poetic. Jeremy Avogad, a logician at Carnegie Mellon University, said in an email. He then built the mathematics of the time on top of that, proving things in such a way that each successive step clearly follows from previous ones, using the basic notions, definitions and prior theorems. There were complaints that some of Euclid's obvious steps were less than obvious. Dr. Avogad said, yet the system worked. But by the 20th century, mathematicians were no longer willing to ground mathematics in this intuitive geometric foundation. Instead they developed formal systems, precise symbolic representations, mechanical rules. Eventually, this formalization allowed mathematics to be translated into computer code. In 1976, the four-color theorem, which states that four colors are sufficient to fill a map so that no two adjacent regions are the same color, became the first major theorem proved with the help of computational brute force. Now mathematicians are grappling with the latest transformative force, artificial intelligence. In 2019, Christian Shigeti, a computer scientist formerly at Google and now at a startup in the Bay Area, predicted that a computer system would match or exceed the problem-solving ability of the best human mathematicians within a decade. Last year he revised the target date to 2026. Akshay Venkatesh, a mathematician at the Institute for Advanced Study in Princeton and a winner of the Fields Medal in 2018, isn't currently interested in using AI, but he is keen on talking about it. I want my students to realize that the field they're in is going to change a lot, he said in an interview last year. He recently added by email, I am not opposed to thoughtful and deliberate use of technology to support our human understanding, but I strongly believe that mindfulness about the way we use it is essential. In February, Dr. Avogad attended a workshop about machine-assisted proofs at the Institute for Pure and Applied Mathematics on the campus of the University of California, Los Angeles. He visited the Euclid portrait on the final day of the workshop. The gathering drew an atypical mix of mathematicians and computer scientists. It feels consequential, said Terence Tao, a mathematician at the university, winner of a Fields Medal in 2006 and the workshop's lead organizer. Dr. Tao noted that only in the last couple years have mathematicians started worrying about AI's potential threats, whether to mathematical aesthetics or to themselves. That prominent community members are now broaching the issues and exploring the potential kind of breaks the taboo, he said. One conspicuous workshop attendee sat in the front row. A trapezoidal box named Raise Hand robot that emitted a mechanical murmur and lifted its hand whenever an online participant had a question. It helps if robots are cute and non-threatening, Dr. Tao said. Bring on the proof whiners. These days there is no shortage of gadgetry for optimizing our lives, diet, sleep, exercise. We like to attach stuff to ourselves to make it a little easier to get things right. Jordan Ellenberg, a mathematician at the University of Wisconsin-Madison, said during a workshop break, AI gadgetry might do the same for mathematics, he added. It's very clear that the question is what can machines do for us, not what will machines do to us. One math gadget is called a proof assistant or interactive theorem prover. Automath was an early incarnation in the 1960s. Step by step, a mathematician translates a proof into code. Then a software program checks whether the reasoning is correct. Verifications accumulate in a library, a dynamic canonical reference that others can consult. This type of formalization provides a foundation for mathematics today, said Dr. Avogad, who is the director of the Hoskinson Center for Formal Mathematics, funded by the crypto entrepreneur Charles Hoskinson, in just the same way that Euclid was trying to codify and provide a foundation for the mathematics of his time. Of late, the open-source proof assistant system Lean is attracting attention. Developed at Microsoft by Leonardo Di Mora, a computer scientist now with Amazon, Lean uses automated reasoning, which is powered by what is known as good old-fashioned artificial intelligence or GAFI, symbolic I, inspired by logic. So far the Lean community has verified an intriguing theorem about turning a sphere inside out, as well as a pivotal theorem in a scheme for unifying mathematical realms, among other gambits. But a proof assistant also has drawbacks. It often complains that it does not understand the definitions, axioms or reasoning steps entered by the mathematician, and for this it has been called a proof whiner. All that whining can make research cumbersome. But Heather Macbeth, a mathematician at Fordham University, said that this same feature, providing line-by-line feedback, also makes the systems useful for teaching. In the spring, Dr. Macbeth designed a bilingual course. She translated every problem presented on the blackboard into Lean code in the lecture notes, and students submitted solutions to homework problems both in Lean and prose. It gave them confidence, Dr. Macbeth said, because they received instant feedback on when the proof was finished and whether each step along the way was right or wrong. Since attending the workshop, Emily Reel, a mathematician at Johns Hopkins University, used an experimental proof assistant program to formalize proofs she had previously published with a co-author. By the end of a verification, she said, "I'm really deep into understanding the proof, way deeper than I've ever understood before. I'm thinking so clearly that I can explain it to a really dumb computer." Brute reason, but is it math? Another automated reasoning tool, used by Mrin Hoyul, a computer scientist at Carnegie Mellon University and an Amazon scholar, is what he colloquially calls brute reasoning, or, more technically, a satisfiability or SAT solver. By merely stating, with a carefully crafted encoding, which exotic object you want to find, he said, a supercomputer network churns through a search space and determines whether or not that entity exists. Just before the workshop, Dr. Hoyul and one of his PhD students, Bernardo Subercaso, finalized their solution to a long-standing problem with a file that was 50 terabytes in size. Yet that file hardly compared with the result that Dr. Hoyul and collaborators produced in 2016. 200 terabyte maths proof is largest ever, a headline in Nature announced. The article went on to ask whether solving problems with such tools truly counted as math. In Dr. Hoyul's view, this approach is needed to solve problems that are beyond what humans can do. Another set of tools uses machine learning, which synthesizes oodles of data and detects patterns but is not good at logical, step-by-step reasoning. Google's DeepMind designs machine learning algorithms to tackle the likes of protein folding, AlphaFold, and winning at chess, AlphaZero. In a 2021 Nature paper, a team described their results as advancing mathematics by guiding human intuition with AI. Yui Tony Wu, a computer scientist formerly at Google and now with a startup in the Bay Area, has outlined a grander machine learning goal. To solve mathematics at Google, Dr. Wu explored how the large language models that empower chatbots might help with mathematics. The team used a model that was trained on internet data and then fine-tuned on a large math-rich dataset using, for instance, an online archive of math and science papers. When asked in everyday English to solve math problems, this specialized chatbot named Minerva was pretty good at imitating humans, Dr. Wu said at the workshop. The model obtained scores that were better than an average 16-year-old student on high school math exams. Ultimately, Dr. Wu said, he envisioned an automated mathematician that has the capability of solving a mathematical theorem all by itself. Mathematics as a litmus test. Mathematicians have responded to these disruptions with varying levels of concern. Michael Harris at Columbia University expresses qualms in his Silicon Reckoner Substack. He is troubled by the potentially conflicting goals and values of research mathematics and the tech and defense industries. In a recent newsletter, he noted that one speaker at a workshop AI to assist mathematical reasoning organized by the National Academies of Sciences was a representative from Booz Allen Hamilton, a government contractor for intelligence agencies and the military. Dr. Harris lamented the lack of discussion about the larger implications of AI on mathematical research, particularly when contrasted with the very lively conversation going on about the technology pretty much everywhere except mathematics. Geordie Williamson, of the University of Sydney and a DeepMind collaborator, spoke at the NS gathering and encouraged mathematicians and computer scientists to be more involved in such conversations. At the workshop in Los Angeles, he opened his talk with a line adapted from You and the Atom Bomb, a 1945 essay by George Orwell. Given how likely we all are to be profoundly affected within the next 5 years, Dr. Williamson said,